Hello friends, SentinalhMC here, and welcome back to our Immersive Engineering tutorial series. In this episode, we're going to be taking a look at voltage and how the Immersive Engineering power system works. As you can see, there's a lot of stuff in front of me, so let's get right into it. In a previous episode, we talked about low voltage, and we also talked about how to transmit power from source to destination by using connectors. However, we haven't yet gone over the medium and high voltage aspects, and it's about time we did, because the diesel engine produces high voltage. So while I've showed you how to make that and use it to produce high voltage current, we don't currently have a way of using it. So let's rectify that situation. I'm going to quickly go through everything that we're going to be crafting, and then we'll go ahead and experiment with it, and so that we can see how it works. So the first thing that we're going to look at how to craft is the medium and high voltage capacitors. We previously looked at how to craft the low voltage version, so here we go. The low voltage version, if you remember, only stores 100,000 RF, while the medium voltage version, you can see here, actually stores, wait, is that 1 million? I couldn't tell if that was 1 or 10. It's 1 million. So that's a pretty enormous increase. So to craft a medium voltage capacitor, you need 2 treated wood planks, a block of redstone, 2 electrum ingots, a lead ingot, and 3 iron ingots. And that gives you the medium voltage capacitor. The high voltage capacitor can store 4 million RF, which is 4 times as much, which isn't quite as enormous of an increase as the previous one, but it's still pretty good. The high voltage capacitor is crafted almost the same way, using 2 treated wood planks, a block of redstone, but then it requires 2 aluminum ingots, a block of lead instead of just an ingot, and 3 steel ingots, so it's quite a bit more expensive. So there you go, the medium voltage capacitor and the high voltage capacitor. It's important to note that you can still connect lower voltage wire connectors to these things. Okay? Alright. Now we've seen how to craft the low voltage wire connector, but now we need to craft the medium and high voltage wire connectors. To craft a medium voltage wire connector, you need 4 blocks of hardened clay and 3 iron ingots, and that will give you 8 medium voltage wire connectors. If you remember, the low voltage connector is crafted using copper instead of iron. The high voltage wire connector is a bit more expensive because it requires 6 hardened clay instead of 4 and 3 aluminum ingots, but it only gives you 4 HV wire connectors, so it's half as efficient as the other ones. Okay, so yeah, but there's a decent reason for that. The high voltage wire connector works differently than the medium or low voltage wire connector, and that's why this exists, the high voltage wire relay. You're going to need this if you want to transmit high voltage current across a distance that's going to require more than one connection. Because remember, these wires can only stretch about 30 blocks before they need another connection point. High voltage power connectors can only have one wire attached to them, which is very different from the other two, which can have multiple wires connected to them. So you're going to need relays in the middle in between 2 high voltage wire connectors. High voltage wire relays are crafted with its own unique material called insulating glass. In order to craft it, you're going to need one... Oh, wait, that's not what it's supposed to look like. It messed up my... What? It messed up my my recipe. There we go. 4 insulating glass and 3 iron ingots gives you 8 high voltage wire relays. Now, in order to craft the insulating glass, you need 1 green dye. It doesn't have to be cactus green. It can be any green dye, just about, from any other mod you've got. 2 blocks of glass and 2 iron dust. In this case, we've got iron grit from Immersive Engineering, but iron powder, iron dust, it'll all work. Well, it should all work from different mods, as long as it's iron dust. Gives you 2 insulating glass, so you need to craft this recipe twice in order to make 8 HV wire relays, and we'll take a look at how to use those coming up here. Next, in order to transform your current from one voltage to another, you're going to need a transformer. The standard transformer can convert from low voltage to medium voltage, and from medium voltage down to low voltage, but it cannot transform into high voltage. It's crafted. Ah, it messed up my recipe again. There we go. It took out my iron as well. What is going on? Deleting my iron ingots. Alright. The transformer is crafted using an electrum wire coil, a medium voltage wire connector, and a low voltage wire connector. It doesn't matter which side of the crafting grid you place it on. And 5 iron ingots. Now, in a previous episode, we looked at how to craft a copper wire coil, and this is crafted exactly the same way. It's crafted using a iron ingot and 8 medium voltage wire coils, and those are each crafted using a stick and 4 electrum ingots, and that gives you 4 wire coils per recipe. If you want to transform between high voltage, medium voltage, and low voltage, you're going to need the high voltage transformer. Now, it's important to note, the high voltage transformer can convert from high voltage down to either medium or low, but it cannot take low voltage and transform it straight into high voltage, I don't think. We can try it, though. The high voltage transformer is far more expensive. I did it again. What is going on? The high voltage transformer is more expensive than the other ones, requiring a medium voltage wire connector and a high voltage wire connector, 5 iron ingots, and a high voltage wire coil, which, you guessed it, is an iron ingot and high voltage wire coil wires. To craft the high voltage wire coils, you need to use a stick and either aluminum ingots or steel ingots. Oh, it's actually steel and aluminum ingots. I don't know why it's on here twice. So you'll need 2 steel ingots and 2 aluminum ingots. Alright, there we go. And that gives you 4 wire coils. As you can see here, you can place a standard transformer against a wooden post in order to greatly decrease its size. And this is great for aesthetic purposes, if you don't want this enormous box sitting around. However, you can't connect the high voltage transformer to a wire post. It will simply pop up in its full-size form. Alright, now that we've crafted all that, hope I haven't lost anybody, I've got some stuff set over here, and we're going to experiment with sending these different voltages around. Now, low voltage can transmit 256 RF per tick max before the wire melts. I recently, in my Let's Play world, had, and you'll see this in the Let's Play Revolution Let's Play tomorrow, my wires melted because my system requested more power than 256 RF per tick. It's important to note that in Immersive Engineering, power only transmits to the wires when it's actually being requested. So, for example, if nothing in your network in your wire network is requesting power, and so you string some like low voltage cables some places, if you then start requesting some power and it's too much and it tries to go through those low voltage wires, they'll melt. And it doesn't just melt the one, it melts all the low voltage wires between the source and the destination. Sorry about that. Something minimized my game for no apparent reason. Okay, so that can be an issue. Now, nothing explodes, but the wires fizzle out and you lose them, so that can be kind of annoying. Medium voltage can transfer 1024 RF per tick max before it melts, and high voltage can transmit 4096 RF per tick max before it melts. Okay? Alright. And funnily enough, 4096 RF per tick is the output of the diesel generator. Fancy that, right? Okay. So I've got here some capacitors that have power in them, and some capacitors over here that do not. Obviously, if and actually these orange sides are the output. So we're going to go ahead and we're just going to whack the top of this because I want the tops to be the outputs. And we don't need any inputs. Okay. So now we have that, and the tops of these are inputs. So if I connect a low voltage wire connector to the output, a low voltage wire connector to the input, and then one on top of this wire pillar just for fun, I can take a wire and right click there, then right click there and right click there, and now power flows from one capacitor into the other capacitor at 256 RF per tick, which will actually very quickly fill this thing up. Now if I clip the wire with my wire cutters, and wire cutters are very useful by the way, it will stop flowing because there's no more wires. Now if I break these and actually place MV wire connectors on here and use the medium voltage cable, you can see that power is still flowing. However, it's not flowing any faster. It's still, because these are low voltage capacitors, they can only output at 256 RF per tick. But you'll notice that there's only 99,744 RF in this capacitor, and we started with an even 100. That's because the wires in this mod do have power loss over distance. So keep that in mind. There is some power loss. Power loss can be quite high if you're not using the right kind of wires. For example, if I needed to transfer power over a very long distance requiring many steps, I would not want to use low voltage wires because they would lose more power over that distance. Generally speaking, when you're transmitting power, in order to minimize losses and maximize output, you want to use the highest voltage you can. That's in real life and in the game. Let's just replace these with fully charged capacitors. So the same thing that we just did would happen for the medium, and it would happen for the high. However, there's a difference with the high voltage. Remember what I mentioned is that you can only have one wire connected to a high voltage wire connector. That means that if I try and stick these up here, I can connect these together, but I can't do that. If I try it, it'll say you cannot attach this wire here, because you can only ever have one high voltage wire connected to a high voltage wire connector. In order to do this, you need to use the high voltage wire relay. Now the relay actually has a pretty interesting restriction. It can only be placed on the underside of a block. I can't place it against the side. I can't place it on the top. It needs to be hung from the underside of something. Now you can actually use these wooden posts, because if you try and place it, this top thing, post thing, will flip upside down, and you'll be able to attach it. Okay? So that's how you do that. Now that it's attached, I can take my high voltage wire coil and attach it to the output, and then attach it over here, and power will flow pretty darn quickly. So it does transmit the power pretty quick. We got 65,000 RF already in here, and we've got only 343,000 left in here. So this sent out about, I guess, 650,000, and this collected 565,000. Power loss is pretty large, actually. That power loss is pretty big. So be careful how long if you're transmitting power over a very long distance, you are going to lose quite a bit. Okay, now let's do some transforming. So if I wanted to take this medium voltage power and I wanted to place it into a low voltage receiver, or if I wanted to start using low voltage wire, that's basically what we're talking about here. I would use a transformer. So I can place this transformer right here, and notice how it set itself up. When you place the transformer on the side of a wooden post, the medium voltage connection will always be on top, while the low voltage connection will be on the side that was facing you when you placed it. So keep that in mind, so that it's on the side facing away from the post. So make sure you place it properly so that you can actually get it connected without being obstructed. For instance, if I tried to place it here, I wouldn't be able to connect it because the connection would be obstructed. Now I can use my medium voltage wire coils to connect. Actually, no, it's supposed to connect up there. Whatever, it'll still work. My medium voltage wire connector will attach to the transformer, and then I can take the low voltage wire connector, and once I place that there, I can then There we go. We are getting power coming in because it is transforming the medium voltage into low voltage. So that's very useful. If you have some machines that you're running on medium voltage, and then you want to, you don't have to want to also run some things on low voltage. You can just place a transformer somewhere, wire the two in, and bada boom, bada boom. You are now transforming, and you can run that low voltage stuff. So yeah, that's pretty useful. So part of your factory or base can be running low voltage, and another part can be running medium voltage. So that's the standard transformer. And it works the same way with the high voltage transformer, except that you can't place it on the side of a wooden post. For the purposes of this demonstration, we'll show off both the fact that you can convert high voltage to medium voltage and medium voltage to high voltage, as well as the fact that you can convert from high voltage all the way down to low voltage. So let us take a high voltage wire and connect it up. Notice that the terminal turned into a high voltage terminal, so you can visually tell what's going on. Pretty nice. Now if I take a low voltage wire and connect it to the transformer, we are getting low voltage power in. Pretty darn sweet. Now, if I take my engineer's hammer, I can actually reverse these. If I turn the top of this into an output and the top of this into an input, you can see that we are currently receiving power at a very slow rate. Because yes, we can go both ways. We are currently transmitting low voltage power through the high voltage transformer into a high voltage capacitor. Okay? So if you're going to go from a high voltage to a low voltage, you can use the high voltage transformer for that. However, we can also convert to medium. So if we take this medium voltage and connect it to the transformer, that will turn into a medium voltage thing. And then if we take a high voltage wire and connect it to the... Okay, you have to start from where you're connecting it to and then connect it to the transformer. It doesn't like to work the other way around. You can see that we are currently receiving power. It's not coming in as quickly as if we connected it to a high voltage source, because we're transmitting a medium voltage source, which can only transmit at 1024, whereas this can transmit 4 times as fast. So you can see how it's slower to transmit. But there we go on the high voltage transformer. Now, because the high voltage transformer is more expensive than the standard transformer, you're going to want to probably use the standard transformer for as much as you can, which is from low to medium. And someone actually said that you can do high voltage, but I don't think you can. No, you can only ever attach electrum to this thing. So that's how that works. The power loss in Immersive Engineering might be a bit higher than it should be. Some people have complained about how high it is. I haven't had any problems so far. I have noticed a bit of power loss. In order to rewire my Let's Play base so that it would actually not burn up my cables, I ran medium voltage from my power supply over to my base and then put in a transformer and then ran low voltage to my low voltage machines. What I noticed is that my little external heated furnace no longer gets up to full power because the power loss is starting to eat into the maximum because I'm not producing very much power. All right, I'm producing very little power with my little advanced windmills. So this is how the power system works in Immersive Engineering. There are additional things there are other blocks and things that you can add to this and use for this, and we'll go over those in the next video. Taking a look at breaker switches and the redstone breaker, and also the current measuring block, so you can see how much current's passing through. That'll be neat. Anyway, stay tuned for that in the next episode. I hope you enjoyed this episode. I know it was pretty heavily loaded. I hope it didn't confuse you too much. It's pretty standard stuff, converting low to medium, medium to high, high to low, low to high kind of thing. Anyway, I wish I had a measurement of the amount of power loss, but I can't find the power loss measurements anywhere. I haven't been able to find it. If anybody has a source for what the power loss actually is, let me know. Anyway, stay tuned for future episodes. I'm SentinalH, and I'm signing out.